Hello friends, welcome to Unacademy, which is the largest online education platform for GATE, CS and IT. Here, myself Malesham Devasani, I am an educator on Unacademy. Here I am going to take the classes for Theory of Computation, Comparison and C Programming on this YouTube channel. Today in this session, I will be discussing about I will be helping you to construct the Turing machine. Okay, before starting this session today, and I will help you to understand what I teach on Unacademy and also what Unacademy can offer you if you are seriously preparing for GATE exam. Okay, let me start about my background details. I worked at various institutes in India, and today I have almost guided in the past about 1 lakh students. And if you want to visit Unacademy and if you want to learn from me and other educators, the top educators of India, then visit unacademy.com/DEVAGATE and this is referral code. You can access all free classes, as well as if you are interested, take you either plus or iconic subscription if you are enjoying sessions from us. Okay, DEVALIVE is my referral code. Remember, DEVALIVE to get 10% discount, as well as to access the free classes at Unacademy. And if you are not aware of these two words, plus and iconic, which are beautifully designed to learn and which is going to help for those students who are preparing seriously to crack the exam, the plus is going to have all courses are well designed and structured, where you will have daily live classes, and every Sunday you will have a weekly test, and every 4th day of the course you will have the doubt solving session. So that is the most beneficial plan. And iconic is more advantage, where you don't know how to prepare, and the iconic you will have dedicated coach to guide you all the time, and you will have a separate designed material, and you will have separate plan to study, and you will have separate booster sessions and many other things too. And if you are not aware of my free classes, if you visit my profile, you will find the quizzes, all-in-one sessions to practice, and special topics on TOCC, CD, discrete mathematics, algorithms, and soon DBMS is also going to come, and daily practice problems and PYQ series of many subjects. So these are the benefits if you are visiting, and more than 400 classes are available on Unacademy. You can go to my profile and you can access to them. Good evening, Shubhasri. Okay, if you are not aware of how to access the Unacademy website or app, so this is Unacademy learning app. You go and install in Play Store, and then you can access to classes from Unacademy. And if you want to access to the if you want access to the Chrome or any other browser, then choose the GATE and ESE. And before that, login. If you require any referral code, you can use my referral code DEVALIVE. And now you can search for any class, that is by visiting unacademy.com. So when you click on get subscription, you will be redirected to one web page where you will have a plus and iconic features, and choose as per your requirement, as I have discussed already, plus or iconic. And then what is the advantage you get? You will get the advantage, a benefit to learn from India's top educators. So that is how you can gain knowledge from the experienced faculty, and many more are joining, and already so many educators are available. And if you are interested for plus, in case, let me help you. 1.5 2 years are very popular than 6 months or 3 months or 1 month. And here you can see the total price after entering my referral code. And similarly, you have iconic plan, where 1 year and 2 years, these plans are very popular, and where you can see the 1 year 45,225 and 2 years 66,600. And do not forget to enter the referral code to get the benefit of a discount. Okay, if you are not aware of some batches, new batches are announced by Unacademy. The first batch for 2022. We are talking about 2022 batches, and as EC and electrical 21st December onwards, and mechanical civil 28th onwards, and CS and IT will be announced soon. Okay, if you are not aware of my daily classes, and morning 8 AM on Unacademy free class on algorithms, and 9:30 AM you will have GATE PYQ series on C programming, and 11 a.m. this is a paid course which is not a free, and 2 p.m. you have compiler design, and 4 p.m. is not started yet, maybe probably start will from tomorrow, and 6 p.m. is already going on GATE PYQ series on discrete mathematics. Second class today happened, and 8:15 p.m. we will meet today here itself on the same channel. Okay, let's begin, and I hope you understood what we are doing. In previous session I helped you to understand what is Turing motion. Now in this session I will help you how to construct the Turing motion. Okay, so this is my agenda today in this session. In this construction I'll mainly help these 5 problems so that you will have awareness how to construct the Turing motion. In previous session I told you what is the definition, what is the configuration, what Turing motion does, what halting Turing motion does. I just spoken about it. Now I'm going to show you how Turing motion can be designed. Okay, the first problem, which is a power n, b power n, where n greater than or equal to 1. And you might ask, sir, will it accept epsilon? Yes, you can accept epsilon. If the initial state is directly blank, you go to final state. Remember that Turing motion can accept epsilon. But only the problem is whether already designed Turing motion is accepting epsilon or not. It is very difficult to verify. That problem is undecidable. Okay, we will slowly understand, guys. Okay, be careful about epsilon. We can design a TM to accept epsilon, but we can't verify Turing motions in the world, are they accepting epsilon. Both are different. Okay, so anyhow I'm avoiding epsilon only for the reason is to make simpler design. Okay, first problem is a power n, b power n. Later I will show you how to construct Turing motion to accept epsilon also. Okay, what is the idea of designing? I told you yesterday, right? So if you have 4 A's, 4 B's, and remaining symbols are blanks, assume it is a two-way table and you are pointing to A. So what is our job? We scan first time, first forward scan, we do something 1A, 1B replace with somebody, and we come back, we do second scan, we will match this A and this B somehow, and we will take again one more scan, we will replace third A and third B with some new symbol so that you can't see when you come back, and A and B. And if you are going again, when you look for A, there is no A, that means somehow we will go further, we will, when you see the blank, we will accept it. So this is some kind of logic, how people design a Turing motion. Now I will help you each and every scan how we are gonna do. Okay, let's move. Okay, same problem. First, Q naught job is to identify A and replace with X. A replace with X. That is the job of Q naught. So Q naught initially pointing to A. It will replace with X and it will move forward, but it gives to Q1. What is the Q1 job? Somehow it has to find the B. The Q1 only one job is to find the B first. So what is the Q1 job? To find a B. When B comes, replace with Y. So we replace with Y. Now here one scan is over. Is that clear? The first scan is over. Now don't go further because we don't have any C to check. If you have a second problem, if you look at the second problem, you can go back and look at. See, A is there, B is there, C is there. Now you can go forward to check, to cross check that do you have a C or not. Now we don't have any C to check. So we take turn back. We do the turn back. So reverse direction, guys. Now we will hand over to Q2. What is Q2 job? The Q2 job is to identify the first A and give to Q0. How will you do that? But Q2 job is to do the reverse scan. You may assume it is a reverse scan. Skip everything. I'm going to skip everything. But how long? How long? How long I do that? When I see the first X here, I know that after this X only A is there. Can you see that? Here A is there. So I'm going to look for the X. Look for the X. So it is going to find the first X in reverse scan. If it finds the first X in the reverse scan, immediately it gives to Q0. Now you know Q0, the job is again same. Same it is going to do. Everybody? Yeah. After first scan, this is the picture of the configuration. Now let's move on to some nth step, because there are so many new symbols you are writing. X and Y was not given to you. You are writing. You should know when do they occur when we scan. So for that purpose, I'm just blindly designing something, because you know I have already replaced with 2x and 2 a's I have, and 2 y's already replaced by if you have the b's, you replace with y, and then you have 2 b's and you have a blank here. Some random step I am taking. Random step to understand. Here Q0 is pointing. Let's focus on how this algorithm works. Yeah, good evening Nishu. Now tell me the same procedure that you have done. Q0 job is to replace A with X and give to Q1. And what is Q1 job? To find the B. But look at that. The first scan, there was no Y because only A's and B's are there. Now you have to take care of two things. You need to skip A as well as Y. But if you look at the first scan, skip A only it tells. But if you do second or third or fourth scan, you will understand what exactly you require to skip. And Q1 job is to replace B with Y. And it turns back and gives to Q2. And what is Q2 job? What is Q2 job? Q2 is pointing to this one now. And it moves till it sees the first X in the reverse direction. What it is going to skip? Previously only skip A, now Y also coming first, then A also. We have to skip two things, Y and A, then only you can see the X in the reverse direction. Everybody? So now let's look at what is the Q0 job. Q0 job is replace A with X and give to Q1. What is the Q1 job? Find B and replace with Y. But to find B, it's not easy. You can find a B if you skip A and Y only. You have to skip two things. A and Y you need to ignore in the forward direction. What is the Q2 job? When Q1 sees the B, it replaces with Y and moves left direction. So Q2 now only moves left, and to find X, that is the first X in the reverse scan, in left direction. That is, that you can find by skip Y and A. You need to do the two things to find that. Everybody? But this is not yet over. So many other things are there. And in the last scan, final scan, what happens? You know, final scan, what happens? Everything is replaced somehow. Everything is replaced somehow. Just let me begin from here. Let me begin to understand this B. Assume that just now Q1 is just replaced B with Y. Then let's look at how it is going to accept the problem. Q1 gives to Q2. And Q2 try to find the first X in the reverse scan. But we don't know after X A is there or not. Right? If A is there, we need to match it. Now Q2 immediately gives to Q0. Then display Q0 pointing to Y. So far in previous all the four scans, Q0 was pointing to A because every A, every B is going to match. Now this time no A means indirectly you should not have a B. So what we do? Here Q0 knows that my job is over. So it gives to, let's say, Q3. What Q3 has to find? It has to look at only Y's so that it should find the B. If you find the B, you can go to final state. So Q3 is a very special. It is going to skip all Y's to find a blank. If it can find the blank, that means the string was valid, so we can accept it. If it is not able to find the B, otherwise you have some B's left, that means string is invalid, we don't have a path in our machine. Clear? The whole story. And without this story, if you start designing a machine, maybe probably you can't end up because you didn't understand the logic of the problem. So logic is always important before the machine designing. It's just like a program, guys, just like a program. So are you ready to design the same concept? But you have to look at this concept to design. Okay, right, everybody? So I'm helping to understand the same situation. Okay, some intermediate step I have taken. Q0 replace A with X. Intermediate step I have taken, remember. So what is the Q0 job? I am designing parallelly. What is the Q0 job? What is the Q0 job, guys? Replace A with X and go to right direction and give to Q1. Is that correct job? Is that correct or not? Come on, guys. We'll go to Q1. And what is the Q1 job? It has to skip everything to reach a blank. Here, to reach not a blank, sir, to reach a B symbol, to reach a small b. So we have to skip two things to reach that. One A might come, another Y might come. So we do something here. Skip A means A replace with A, take right. That is a skip A. And skip also Y. Skip also Y and move right direction. And when you get a blank, so what do? When you get a blank, not a blank, when you get a B, what I am saying blank. When you get a B, replace with Y, take left, take left, take left. So what happened so far? Here first A is matched with, replaced with X and another one B replaced with Y. So one match is over. 1A, 1B is matched. We cancelled 1A, 1B indirectly. We remembered 1A, 1B indirectly. And now we are moving left direction because one scan completely over. One scan completely over. Come on, guys. Fine. Now what is our job? We have given to Q2. We have given to Q2. What is the Q2 job? What is Q2 job? To find out the first X in the reverse direction. How do you do that? How do you do that? For that, you need to skip so many things. You need to skip Y and A. You know that. I told you in the previous one only. You need to skip. First Y will come and A will come. You don't need to worry about who comes first because already we ensured after A only B's are coming in the path. Okay. Skip Y but left direction. Skip A but left direction. How long? Till it sees the X in the reverse direction. First X when it comes and you hand over to Q0. Everybody? And over to Q0. That is the first X. And when you see the first X, keep X only, but change the direction, move right, because now new scan begins. New scan begins, and if Q0 finds A, and it will keep on doing that same path. Everybody, this is gonna replace every A with X and every B with Y, every B with Y. But how long? As long as A's are there in the input, it's going to do that. But once A's are over, just now I told, Q0 is going to see something. What is that, guys? Q0 is going to see the Y. Actually, Q0 never sees the Y, but first time when it sees the Y, it means A's are over. Then you have to do one thing. What is that? Ensure only Y's are there. Because after Y, if B left, then A's and B's are not equal. So now we go to, this is a Q2, let's say. This is a Q3. Now Q3 job is to see only Y's. That means previously only B's are there and all the B's are replaced with Y. Then you can go to final state. If you see the blank, that means my input has equal number of A's and B's. And in the last step, you can move left or right, doesn't matter because I'm going to final. everybody, and this is the complete machine. This is a complete machine, guys. And look at it, just like a program. I have 5 functions. Every state has a different functionality to think about, right? You should know which order of these states you need to change. From Q0 I can go to Q1 or Q3. From Q1 I can only go to Q1 or itself I can call. From Q2 itself I call, or I can go to Q0. So you should know how do you change the states depends on your logic. Is this the only way I can design in the world? No, guys. You can have different logics to design on your own, right? You can. In case I want to accept epsilon now, from Q0 directly you may see the blank, go to final. That you take additionally, that is from Q0 on blank you can go to final state, that's a QF, if you want to accept epsilon. But anyhow epsilon is not there. If you want to accept empty string, from Q0 on blank directly give a transition to final state. Clear this point, everybody? And we have designed a machine, guys. We have completed a machine. Now I'm going to show how do you represent other ways. You can also construct a table. For this. How? We have Q0, we have Q1 and Q2, Q3. Okay, last one is just dummy. It's a final state. We don't have any transition from final because we designed such a way that there is no transition from final. Okay, A, B, and we are going to look at blank. Okay, now let's take this is A and B, and also we have I think X and Y also can come, right? Okay, it looks complicated. Now many columns are coming, guys, so you need many columns too. So I just avoid designing a table because it requires too much length. Just I will show you one transition how to do that. I'll show you one thing. Remaining you can do on your own. One representation looks lengthy now, so I will show you for one row. Remaining you try, guys, because looks A column, B column, X column, Y column and blank column because of all the tape symbols. A, B, X, Y, blank. And from Q0 on A, what do? You go to Q1 and you replace with X, take right direction. And on B we don't have a transition, you might go to dead state. And on X we don't have any transition. On Y we have that we go to Q3 and Y replace with Y and we take right direction. And on blank, if you want to accept epsilon, go to final. There is no epsilon, so leave it. Is that clear? Q0 I have shown. Similarly you can write for Q1, Q2, Q3, Q4 and so on. Everybody? So I will also help you for Q1, but be careful how to do for remaining two. I will help you for Q1. Okay. So tell me on A what it does? Skip. So same state. Self loop. A replace with A, move right. And B we have. And there we go to Q2 and we replace with Y, but we move left. And on X, no transition. On Y, yes, self loop is there. Q1, Y, right. On blank, no transition. Similarly, every state you can fill up. This is the table representation. Even you can do something like that, delta of Q0, A is equal to, you can write Q1, X, right. Delta of Q0, Y, you can write Q3, Y, right. You can also write transitions. And so many ways to represent the Turing machine. You can draw the diagram, you can construct the table, that's a delta table, and you can also use mappings. Fine? Let's move on to the next problem. And guys, if you are watching this video, please like this session. You know the effort that we take, and it's for you, and we only expect one thing from you, that is just like. And the second problem, now we have a very clear picture about the a power and b power equal number of a's and b's. Now we want 3. So now how many things required? So directly I will go to the intermediate step, but I will help you first. Suppose I have 4 a's, 4 b's and 4 c's. If the string is not this, we will never create a path. Remember that. We will never create a path that goes to final. If any string you give other than this kind of string, then we will not create a path to the final. Remember. Okay. Now what is our target? This A and this B and this C we are going to compare it in one scan. So that this is going to be X, we replace Y, and let's say this Z. And similarly in the second scan, this is the first scan. Second scan, somehow you have to identify and this position somehow using reverse scan. You just did using Q2 in the previous step, previous motion. And this time 1A, 1B, 1C we cancel. Cancel means we remember it. We remember means we write with somebody else. And in the third scan, and somehow you need to identify this A and this B and this C. So that this A and B and C we remember by writing with some other symbols. Because we don't have a stack or any other things, we can remember by writing only here. And the fourth scan, it's going to replace A and then B, then C. What happens now? And when we are doing the fifth scan, then Q0 is trying to do in the fifth scan, the Q0 points to very special. The Q0 is going to point to this one. Why? That means we understand, okay, our job is over. Somehow we will reach the blank by only looking at Y and Z. Only Y's and Z's are there. Only Y's and Z's are there to reach the blank. Then we go to final. Everybody, that is our target. That is our target. Right? Last scan is to understand acceptance. Remaining scans understand the comparison between A, B and C. Are you ready to do that? Are you ready to do that? Now tell me how many functions you require, like how many states you require. Q0 job is to replace A with X. And what is Q1 job? To replace B with Y. Other jobs are, other functionalities also there to skip something. Okay, we will do that. And what is Q2 job? Now Q2 we don't do reverse scan. We replace C with Z. Now we will do reverse scan. Q3 we can do reverse scan left direction to find the first X. Reverse scan we do to find the first X so that Q0 can start just after the first X. Everybody? Everybody? Clear? And Q4 we may use later on when Q0 sees the Y, then go to Q4 and skip Y and Z. Q4 also we can use in future once the ABC over, then Q0 knows that when it sees the Y and skip Y and Z. Skip Y and Z to find blank. That is similar to the previous one. Yeah. Now whole picture, let me help you with the intermediate steps so that you will understand what to skip, what to replace, what to skip, what to replace. So I am assuming guys, there are so many X are there and so many A's are there. 3X, that means 6 A's and 6 B's and 6 C's. Intermediate step I took after 3 A's replaced with 3X. Now assume that Q0 pointing here. Every step you should have a clarity what you are trying to do. And Q0 replace A with X. That is the job of Q0, right? And move to Q1. Now Q1 job is to find the first B. But to find the first B, you need to skip 2 things. What do you face? You will face A, Y, Y, Y. So skip A, comma, Y. Everybody, skip A, comma, Y. Now don't replace B with Y first. First skip A, Y so that you can go to B. Remember that. Q1 job, there is one more extra. Other than replacing B with Y, you need to skip A and Y by staying in the Q1 itself. Everybody, stay in Q1 only, but skip A and Y. And first time B replaced with Y, and immediately it gives to Q2 because Q1 job is over. Now Q2 job is to find the C. To find the C. But very difficult, guys, because it has to skip B and skip Z. Then only you will reach C. So skip B comma Z. So that the C can be replaced with Z, and now Q2 handovers to Q3. What is Q3 job? Q3 scan, reverse till the first X comes. Now why are you not looking at everybody? Just I skip. I don't care who is there because I know in the forward scan what I did. Skip, Z also comes, and before that B comes, then Y comes. Look at that. In the reverse scan what you are going to get? Z, B's and Y's and A. When you see the first X and give to Q0, yes or no? And this is going to help you every A replace with X, remember. Similarly, every B and C also replace with Y and Z every time. Now this is going to work except to the last step. Except to the last step. What is the last step? When all the A's are replaced with X, then you should guarantee all the B's are replaced with Y, all the C's are replaced with Z. That is the last step. Then how that is going to happen? You have 6X, 6Y, somehow 6Z, and blank is there. And Q0, this is the last step. How to accept input. How to accept. Q0 when it says Y, you can go to Q4 because now Q0 job is different, right? So Q4 only skip Y and Z to reach the blank. If that is true, then come to final. Then go to final. Everybody left, right, doesn't matter which side you move. Can we design the machine now? Can we design the machine? You should remember everything. Then only I can do all these things. Whenever you confuse, we will come to this slide. Okay, ready? Sorry. Can we design now? Okay, let's move. Let's design. Let's design. Q0. What is the Q0 job? Always look at what is the Q0 job. Replace A with X and go to Q1. Speak that English language. Replace A with X, take right direction. Right? And what is the Q1 job? Is to replace B with Y and take right. Take right. Because C is there to go on. But here we might skip so many things. What we skip? What we skip, remember. Skip A and Y. Skip A and Y. Can you see that? You need to skip A and Y to find out that small b. Skip A and Y. So I'm going to do that. Skip A right. And Y, previous B's, now they are Y's. And Q2 job is to find C. Replace with Z but take left turn because complete scan is over. But Q2 has to skip so many things. Right? Q2 has to skip all the B's which are left now. And previous C's were written with Z. That Z's also we need to skip to reach the current C's. Right? When you confuse, go back and look at what is the job of the Q2. It will skip B and Z to reach the C. I did the same thing. Skip B and skip Z. And what is the Q3 job? One scan is over. Now you need to do the reverse scan. In the reverse scan, what symbols comes? Look at carefully every symbol. You can also imagine, but let's focus on Z, B, Y, A. This many things you need to skip to see the X. C will never come because C is their right side to Q3. Okay, now Z, skip, and when you're coming back just after Z in reverse scan, you might see B's left, and you might see Y's, skip, and you might see A's, skip. Then you may see X. Then when X comes, take right direction. Here two things are important. When you take right, when you take left, you must be careful. That means the scan, we are going to do opposite scan because we did something, we detected something there. Everyone? Yeah, this is going to do entire job except the last acceptance. If you want to accept, the Q naught will see something, that is, it will see the Y, means there is no A left. After X, Y is coming, means there is no A left. Then YY, take right and go to Q4. And what is the Q4 job? Guarantee only Y's and Z's are there. And we know after Y only Z we replaced. Then no need to waste your time to change the state. So Y's, Z's, once you skip, you will get a blank after some time. When you get a blank, then go to final state. Go to final state. Everybody? Yeah, I'm not accepting epsilon. If I want to accept epsilon, from Q naught I will see the blank, I will go to final directly. Clear? And this is gonna be easy if you work on manually. Before designing a machine, you must know what you are gonna do. But it is really challenging if somebody is designed. Understanding is really challenging in the world. Like that somebody written program, you want to understand. Really, you may not understand sometimes because of the complexity of the problem, right? And this is also same applicable to Turing machine. Simple Turing machines you may understand, but difficult Turing machines, maybe you take days or hours or months, years to understand. Okay, that's better to design on your own if you are solving a problem. Okay, so let me help you. Before starting other problems, let me help you something. Guys, you know, on Unacademy, we always recommend to go for plus or iconic. The reason is you have structured courses from the top educators of India. That is the best benefit you have. And multiple courses for the same subject. You can learn the same subject from different educators too. And study as per interest, because we are going to launch the batches. You can join every batch or you can join any batch. But when you have the time, you can learn multiple times the same subject too. Learn from top educators. That is very, very important. And study with proper planning. You can plan as per batches. And you will enjoy a lot learning because of the best educators are going to teach on Unacademy. Fine. Let's move on. Let's move on to the next problem, guys. W power R. And what is this problem? You know, this problem is the context-free language, which is not a DCFL, right? We know that. We have a PDF for that. And we also have a Turing machine, guys. But we don't have a finite automata. We don't have a finite automata because it's a non-regular. And you know all these points. It is non-regular. It is not a DCFL. And it is CFL. So it is recursively enumerable language also. That means we don't have a finite automata. What we have, PDA exists, Turing machine exists, but no finite automata for this and no DPDA for this. Now you already know how to design a push down automaton which is non-deterministic. Now I'm going to help you the Turing machine, guys. Turing machine. Now how we can design a Turing machine for this? Clear this point? Okay, let's focus on this string. What gonna be the logic for us? Okay, let's try something. First, form a logic. Is this a palindrome, even length palindrome or not? Even length palindrome or not? Everybody? It is even length palindrome or not? How do you know that? If this is some W and this is definitely reverse of the W. W power R means reverse of W. Yes. Now I want to build a Turing machine for this. So you must have your own logic, because here thousands of logics are there in the world. Thousands of logics are there in the world. And now which logic you want to follow, first you decide. Based on your knowledge, and find out how do you want to implement. Is it clear? And you don't need to learn my way, but I can explain only one or two logics to implement in this session, right? One logic I will explain. So first thing is, what logic you want to follow. Let's decide ourselves. Okay, let's decide ourselves. So I want to do something. In every scan, I do one thing. In every scan, we will find out first and last symbol must be same. First and last symbols are same in every scan. But how can you guarantee first and last? The next time could be second, right? So what, that is the trick now. That is the trick now. Let's focus on this point. Focus on this point. A, B, B, A, B. And then reverse is B, A, B, B, A. Now look at our trick. Look at our trick. First what I do is, you need to remember this. What is this? What is this? A. If A comes, let's say you are in Q0. If A comes, go this side. If A is first, if A comes first, go this side. If B comes first, go this side, because the last symbol should be same. If you don't remember A or B, how can I guarantee last symbol is also same as the first? Clear this point? If the first symbol is A, go different path. If the first symbol is B, do another one. So in this side, guarantee last symbol is also A. And in this side, you need to guarantee last symbol is B. Then how do you guarantee? Look at that. But A comes, I will completely replace with blank. But I remember, I go to last somehow. How do you know last symbol? When the blank comes, take turn and look for this. Yes or no? Look at what I did. When the blank comes, I took left turn. Next symbol before blank is the last symbol. It must be A. That is the palindrome concept. And what I do, I will replace with blank. Why? Because when I start again this looks like a new problem now. This looks like new problem. Now next time I look at this blank, I remember it. Because this side I am going now. Other side, second side. Remember it. But I replace with the blank. Now when I go here, the blank, and they take left turn. Oh, not this blank, guys. That is not the blank now. That is a blank, but this is the blank. Now here you will see the blank. Immediately take left turn and look at this. Now this is the same. So we will replace with the B. Everybody, similarly, we will do every time scanning like that. And when we stop, when we are not able to see the small a or small b, we will end up here. Clear this point? Clear this point? Let me help you now. Complete algorithm. Now, look at, so far I was giving an idea how to understand the problem. So far I was giving an idea. Now I will help you completely how we gonna do. Okay, how we gonna do. Okay, so let's start. B, this is A, and don't look at anything. Don't look at anything. Here, anything is possible. This is, let's say, Q0. Q0, when it sees A, we replace with blank. That is the job. But now you will go to Q1. What is the Q1 job? Q1 job is to find the blank only. Blank only. Because when it sees the blank, it knows that, okay, before the blank, A should be there, because you remember the path. You remember the path. So it gives to Q2. Now Q2 has to see at any cost A only. So A we replace with the blank. Now what is the Q2 job? Q2 job, once A replaced with the blank, the Q2 job is over, give to Q3. Q3 job is to scan from here onwards to find the blank, just like the previous problem. When it sees the blank, and it give to Q0. Now Q0 is going to repeat this process again, same way. Everybody, again. But there is another choice you have. What is another choice? Q0 might see the blank. Here it could be small b. Here it could be small b. If it is small b, the next time you will have this situation. You will have this situation, yes or no? Here Q0 seeing that. Now this side, this time you should not go in the same way. Now what do? This small b you replace with the blank, but don't go to Q1. Now go to Q1 dash. because this path is different. This path is different. Everybody? Now Q1 dash is just like a Q1, but Q1 dash is something different. It knows I am looking for a small b, and it gives to Q2 dash, Q2 prime. Q2 prime is going to replace small b with the blank. Now you can give to Q3, same Q3 you can give. Q3 job is again same. It will find out the blank and give to Q0. So these two kinds of transition will guarantee every A and B is matched in the first and last, no doubt. And if you keep on doing this, one of them definitely happens. One of them definitely happens. In the last scan, you don't see any AB. What happens? Q0 directly sees the blank. Then go to directly final because you are coming in reverse direction, right? One forward, one reverse. If Q0 seeing the blank, means W power R is also over. Q0 was not able to see A or B, means Q0 was seeing the blank. Any other situation, we never go to final. Clear? Yeah. So now, can we do something now? Can we design the machine, guys? Can we design the machine now? Everybody, you must have a logic, everything. So let's start it. Let's start. Q0. First we will go for A path. A path, guys. A path. A replace with the blank and take right and give to Q1. And this is A path. So finally last symbol has to be A. What is the Q1 job? Skip everything. A's and B's only we need to skip. A's and B's only we have to skip. And if you keep on skip, after some time you will see the blank. And when you see the blank, take left turn. Just before the blank, you have to see at any cost, small a only, small a only, small a only. Then replace with blank, take left only. Now move left. And Q3 job is to skip everything. Now 1A, 1B matched. 1A and 1A is matched. Not a 1B, 1A, 1A match. First A, last A. We have a match. Now we need to scan reverse direction. How long? You have to see the blank. So every A skip left, every B skip left. And when you see that blank in the reverse direction, just take one right turn. Then immediately Q0 start, it will job. If A comes, you go upper path, and if B comes, you need to copy paste the same path. Same path, guys. Small b, blank, right? And instead of Q1, go Q1 prime. What is the Q1 prime job? Same as like Q1. Skip everything. But if you go there, you will forget is that A or B, you need to do that. Now go to Q2 dash. And here, and guys, what is the Q2 job? Here now. Here, what is the Q2 prime job? Q2 prime, it has to replace small b with the blank, and you can go to the same state. And here only to remember the small b, we went to different path. Remember that. Otherwise, same path could have been helped. Now, this thing is going to do, to replace every A in the beginning and at last, every B in the beginning and last. Now, if this is going to happen forever and till the old W power R completes in the reverse scan, then Q0 is going to see something that is a blank. When Q0 sees the blank and take any turn, doesn't matter, we go to final. Now guys, here epsilon also accepted. Remember, epsilon, if you have epsilon in the language, Q0 directly see the blank, because on the tape, you don't have anything, only blank. Q0 sees the blank, means it could be epsilon also, because there is no AB. By default, Q0 points the first symbol of your string. When there is no symbol, Q0 points the blank. Even epsilon is also accepted now. Everybody? Yeah, this is a machine you need to understand. Yeah, good point. Over. And first you need to understand the logic, then design it. Directly, if you are trying to design, you might do a lot of mistakes. Okay, now we will move to, okay, If you want, you can take homework. You can take homework. Shubhasri, we don't show non-final. We assume any missing combination that goes to dead state. Is that clear, Shubhasri? If I don't cover anything, suppose last I want A because first I have seen A. Then if it is not A, all missing transitions, if you see the B, go to dead. Because Q2 cannot see the B. And any missing transition, just assume we are going to dead state. Clear? Okay, just assume. This is the best way to design. Homework, anybody want to design a new problem? Homework I am giving. W ash, you know, it is a DCFL. It is a DCFL, right? Try this. Try this. Try this. What you have to do? Just you have to do here ash, comma, right. And same thing here, ash, comma, right. Here same thing here, ash, comma, left. Everybody, now Q0 is going to see the ash at the end. That means after ash, you need to guarantee there is nobody left. Okay, just try that. Yeah. Decidability and decidability will happen after Turing machine, just after 1 day. Tomorrow, I will be talking about closure properties. Tomorrow onwards, undecidability begins. If you miss tomorrow, undecidability is difficult for you. So next session is going to be closure properties. Closure properties is the beginning of undecidability topic. Yeah. Fine. Just do homework. Now, one's complement of binary. Already undecidability chapter begin. Because without Turing machine, okay, who is that? Darab Ahmed Khan. If you don't understand the Turing machine, please don't study undecidability topic. Everybody clear? If you want to understand undecidability, you need to understand Turing machine. Directly, it's not a single topic. Fine. Be careful about undecidability. Entire TOs, you must study all the basic concepts before undecidability. Okay, the first complement of binary. Guys, you know, this is a different machine. Let me help you before that. Turing machines basically can be designed many ways, guys. Turing machine. Most of the people, they're surprised by looking at Turing machines. You can design for acceptance. We can design for acceptance. Acceptance means W belongs to L. Show me that, you will alternate final. If not belongs to L, don't show anything or show you will alternate non-final. If you don't show anything, I will assume you will go to dead and you will alter there. Okay? And this is the first point. And we can also design to produce an output. We can design to produce output for given input. There is no final state now. To produce like a Milli and Murray machines. To produce output for given input. Sometimes without input also you can do that. Right? These are basically producers. You are going to produce for the given input. And other one, Turing machine, we can also design to halt. We can design to halt. There is no final non-final concept. Just halt whenever you observe my property. It's a property based. Whenever you see my property, just halt. There is no final non-final. I can design a machine halt when you start with A, halt when you start with B. Here not acceptance. There is no meaning of acceptance. Halting nature. This is halting nature. Halt when you see my property or my condition. This is produce output for given input. Any input I give, produce output. This is accept valid input. Accept also correspond to halt, but halt need not correspond to accept. Both are different. Everybody? This many ways you can design a Turing machine. I don't know. There could be many Turing machines too. These are the general standard Turing machines, guys. Everybody? And every problem you can't do the same way. Every problem you can't design the same way. Some problems, some programs when you write, you may understand your input. Some programs they produce output. Some programs they take input, they produce output. Some programs they will tell you what we observed. Everybody? So it's all difficult to explain right now, but let me talk about this next problem. Now this behavior is, if I give you 0, 1, 1 as an input to your Turing machine, it will produce. How can we produce output without input? Can you write a program to produce output or not? Shubhasri, the parameters are there inside. You can decide. Right. Basics first. Even finite element can produce output without input. Follow that. Example, traffic light. There is no input to the traffic light change, but output automatically shows or not? Yes, it's a finite behavior, you can do that. Similarly, Turing machine, I can define most of the parameters inside the machine. I can produce like only prime numbers. I can do that. I can produce only even numbers. I can do that. Right. You can do that without any input. Fine. Everybody, now what is the behavior, guys? Here, there is no final state and non-final state. Here, final states are not required. Here, just show me, you will alt just after producing the output. Or don't tell me anything. Once the input is over, I will observe the output. It is your choice how do you design. So let me show you one thing. Halting machine I will design. Okay. What I do is 0. I will replace with, everybody knows, 0, 1, 1, blank is there, blank is there. What we do, one's complement means 0 replace with 1 and go further. 1 replace with 0, go further. 1 replace with 0 and go further. When blank comes, halt it. When blank comes, halt it. Show that you halt it. Or don't show anything, we assume that automatically. So 0 replace with 1, take right. And 1 replace with 0, take right. It's enough to understand every binary number, one's complement. But when you see the blank, just tell that to the world, I replace with blank. Any direction you go, say that to the world, I am halted. Now observe the output. Now when I look at the output, 1, 0, 0 is there. You may use the input type, output type separately, or same type for input, output. First put the input, then after halting, look at the output. Do you have any final state here? Do you have any non-final here? No, because every input I have covered transition here. So I am trying to show you what is the output produced after reading complete input. Everybody? And this is one kind of machine which is very special. There is no final, non-final concept. You give me any input, any binary number in the world, I will complete my input, I will show you, I will halt. Clear? The previous machines are designed to understand acceptance. These machines are designed to understand the halting nature. For any given input, they will produce output and they will halt at the end of the input. Look at that. For any given binary, this TM produces what? One's complement and halts after reading complete input. Remember, not in the middle of the input. Sometimes you can do that, but this problem requires complete input. After completing an input, after completing input, or after completing the job, Clear? Yeah. So let's move on to the choose complement. Guys, choose complement. You can do many ways. One's complement plus 1. There are many logics, right? One's complement plus 1. This is logic 1. There is another logic also. Logic 1. What is another logic? Another logic. If my number is there, any number is there, what do you do, guys? What do? You will search for the first one and keep this are the same in reverse scan and keep same. But this thing do the complement 1 0 1 0, and this is choose complement of above input. Yeah, everybody. But you need to understand logic 2 because I'm going to do the logic 2 here. What is the job? If I give you any input, if I give you any input here, what do? Q0 is pointing here. What do? Scan, scan, scan till the last. When Q0 sees the blank, give to Q1. What Q1 should do? It starts searching for the 1. It starts searching for the 1. This one. When Q1 sees that 1, it does nothing, but it will change the state. It will change the state. Now onwards, Q2 job is to replace 0 with 1 and 1 with 0, 0 with 1, 1 with 0, and when Q2 sees the blank, and halt. Halt. Clear? Come on, come on. Is it clear? The Q2 job is just 1's complement. Can we do that? Can we do that? Let's start. Let's start. Q0. What is the Q0 job? Forward scan. Skip every 1, 0. That is 1 replace with 1, take right. 0 replace with 0, take right. Then only you can go to the last. Then only you can go to the last. And blank. And if blank comes, take left turn. But give to Q1. What is the Q1 job now? To find out the first one in the reverse scan. For that, it has to skip many zeros, guys. To find this, it has to skip all zeros. All zeros, remember that. Then only it can reach the 1. 0, 0 left. So it is going to skip every 0, 0, 0 till the first one. When the first one comes, its job is to keep the same one, but move left, but go to Q2. Happened nothing, but you identified the first one. After the first one, you are going to do the 1's complement. 0 replace with 1, move left. 1 replace with 0, move left. When blank comes, stop. When blank comes, keep the blank. Any direction is okay. Halt. When I halt, I look at, I can see the 2's complement of an input. Everybody? But if you don't know 2's complement of a binary number, first you should learn that. I have already helped you. If you are not understood that 2's complement logic, just look at it. This is given number. This is given. And what do you do? First 1's complement. What is the 1's complement? 0, 1, 0, 1, 0, 1, 1. Add the 1. 1, 1, 0. And carry. 1, 1, 0. And carry. And 1. Right? Then 1, 0, 1, 0. Is it same as this one? You can see that these two are same or not? Yes. Whether you do logic 1 or logic 2. This is a logic 1, guys. This is a logic 1. It is the same. It is the same. Yeah. I hope you understood how to design the Turing machine for this choose complement binary. And Turing machine can do even multiplication of 2 numbers and x power y and x factorial, so many. But already these logics are so difficult. Now look at, guys, what Turing machine can do. A TM can do, if you want to, you can design Turing machine for addition of 2 numbers, unary, binary, doesn't matter. Multiplication you can do. Even addition can be done by even finite automata. We have seen in finite automata with output. And not only this, if n is given number n factorial, if n is given number 2 power n, and you can sort given n numbers, and anything. Today we have a logic that you can do with the Turing machine. That is what today we understood. When we have a logic might be difficult, logic may take days or years, but still when you have a logic, you can build a Turing machine. That is the conclusion of the construction of a Turing machine. But don't assume Turing machine always have final states. Don't assume any other thing. You don't fix the concept, right? There is no restriction. How do you design Turing machine? You can change the configuration of Turing machine if you really require. You can assume put some number and start doing it. Okay, try yourself. Okay, fine. Just ask your program. How do you write a program? Look at that. I will show you guys, everybody who knows the program. Without giving input, can you take or not? X is equal to, is it able to print or not? You have not given any input, but it's able to print or not? Exactly same way. There is nothing, but you take assumptions. Q0, you want to print 2, then blank replace with, let's say, something 1, and again go to Q0 and Q1 and replace with 1, and after replacing 2 ones, go to halt. That means I printed 2. I printed 2. 2 ones means I printed 2. Everybody guys, because I designed that way, Q0, when it sees the blank, I replace with 1, take right, and Q1, when I replace one more blank with 1 and take right, and then I'm going to halt. Now when I halt it, you will see on the tape, you will see 2 ones means I produce the 2. Did you see that? You have not given any input, but I produced 2 ones. I produced 2 ones, and there is no difference between this program and this Turing machine. Yes or no? Come on, Shubhasri, are you clear? Thank you, Varun. Everybody, are you clear? So this is how a Turing machine can produce something without giving an input. It's just like a program. You can do as per your need of the program or logic. Yes, so just do. And we don't worry about much. We don't worry much about when we have a program, assume we have a Turing machine. Remember that. When we have a Turing machine, we have a program. Okay, now guys, this is our session, and if you want to attend my free classes, these are my free classes on Unacademy, except 3-1. You can catch me on Unacademy, and on YouTube anyhow daily I am coming to take. From tomorrow onwards, the already undisability concept started. Anybody understanding the Turing machine means you are already started thinking about the problems in the world. Remember. So yeah, exactly. If logic exists, then TM exists. That is a good point. Fine. If anybody not aware about the plus, then please know about, we have the live interactive classes which interface is beautifully designed. When you have the doubt, immediately ask us, we will help you. That is the beauty of interaction with the educator, interaction with the educator. Immediately the doubt will be clarified, and doubt solving session separately, and weekly test. And this is how the structured courses are designed for you. And Iconic, in case you don't know how to prepare for GATE, will be assigned with a coach to have some kind of a push to prepare with a confidence, and you will have a separate material, and so many beautiful points are there, study planner and study booster sessions, all are for Iconic people. And please take the subscription using DEVALIVE referral code. We are there to help you all the time. The top educators of India are going to help you to learn something required for you. Okay, so this is my profile. If you want to follow me, unacademy.com/DevaGateCSC guys, and this is our Telegram channel to subscribe, Unacademy Gate CS, and we will update the links and material there if we need. And we have so many YouTube channels which are taken by the top educators of India who are working as educator on Unacademy. So please share these channels with your friends so that they can also learn like you. And thank you so much. Please don't forget to like the session and share if you feel that it is very interesting session. Please share with your friends and subscribe to this channel if you want to learn more from us. Thank you. See you guys. Bye bye. Take care.